Alright, so welcome friends, and in this project we are using OpenAI's text embeddings to classify restaurant reviews into positive, neutral or negative sentiments without training a model. In case you are a beginner not aware about embedding at all or how to create embedding through OpenAI model, please visit my previous tutorial on the introduction of embeddings in OpenAI. In this project, we will be classifying restaurant reviews as positive, negative, or neutral using OpenAI's powerful embedding model. Instead of training a machine learning model, we'll be using a zero shot classification approach by converting both the reviews and sentiment labels into embeddings. By measuring the semantic similarity or the cosine distance between the review and each sentiment label, we will predict the sentiment of each review based on the closest match. And in case you have started working with OpenAI's API for text embedding and looking to apply your understanding of cosine distances, this is a perfect tutorial to build practical understanding of using embeddings for classification tasks. By the end of this project, you will be ready with the structured form of review, each review associated with its predicted sentiments. So let's head to Jupyter Notebook and let's get started. As a first step and as a prerequisite to this script, make sure that you have created a developer account with OpenAI, you have added your payment method, you have installed OpenAI library and loaded OpenAI key securely in environment file and fetch it through load.environment library in Python, and finally that you have created OpenAI client using your OpenAI key and so that you can finally make API calls through chat completion and embeddings. And in case you are not aware of these steps in detail, please follow my first tutorial in this series, which is setting up environment for OpenAI. And so let's proceed from there by duplicating this script which we created in our first tutorial so that we can proceed from the next step from this point where we have already created client. So once duplicated, you can adjust the title of the script and we will start from here. Once we have created client, we will begin with loading of data. To load data, make sure that you have the CSV file related to restaurant review in your folder. You can obtain the resource file from the GitHub folder itself, which is mentioned in descriptions. To load data, import pandas and use its read CSV method to load the CSV file. We can have a look at the top few rows using df.head method, where you can see there are different reviews in the review column, and we can fetch all the columns with the help of toList method. So let's do testing only on limited number of reviews so that we can save our token usage over here, and then you can apply later on all the reviews. So I'll just fetch the top 5 reviews in a list. So we have a list of reviews where there are 5 reviews and we'll be going ahead with this. In our model, we have specified text embedding 3 small model from OpenAI, and this is what we used in our last tutorial as well. In our last tutorial, we passed one input at a time through the embedding method to create a request to the model. This time we can pass the input as the list. This will be more efficient way in case we have to generate repetitive embedding. And what we can do, we can fetch the response of the model in a dictionary so that we can access each and every embedding belonging to different elements or different text of the list through model_dump method. So let's see what we get over here. So we will get embeddings in the list for each and every element of the list, which we can access through data. And to access the first embedding, we'll pass 0, right? Because values of the key is a list. From the 0 element, we can fetch the key embedding. So that should give you embedding for one element, one text out of those 5 values of comments We can again check the length of each embedding, and it will turn out to be 1536, as we already know from the previous tutorial that the embedding vector has 1536 dimensions. Instead of this, we can also create a reusable function, wrap the embedding process in a function for easy reuse. So let's create a reusable function where we can pass the list of text, and we can have the same thing over here. So instead of this, we can pass text over here. In return, instead of returning it like this, what we can do, we can first have the list, and for each data, right, for each element in this response dict data, let's create a list through comprehension method, and we can fetch the embedding for each data for data and response dict. So this should return embedding for each element. Let's run this. Let's generate a list of review underscore embeddings using this method, where we are passing the list top 5, which contains top 5 reviews. We'll just comment this out. So we have review embeddings, and let's have a look at the first element of this list, and again it will give you the same results. So first element length, maybe we can check for, right. So this gives us what we expected. Now let's text embed in the same manner using this function the different classes of sentiments which we have taken currently as positive, neutral and negative. Let's store it in a dictionary called sentiments, where we have 3 labels of sentiments currently. We can make a list out of this for each label. Let's call them class. So again, we are fetching the label positive, neutral, negative from, and having a class over here. All we have to do to create embedding is we have to pass this list. Let's see what is there in this list. So this is the list, and all we have to do for creating embeddings, we have to pass these values to our create embedding methods. We will come up with the embeddings of these different sentiments. So we have 2 embedding lists now in place, class embeddings and review embeddings. As a next step, we have to find the closest sentiment using cosine distance, and again we will apply our understanding from previous lesson, where we use the cosine distance to measure the similarity between 2 vectors represented by embeddings. And in case you do not know about cosine distance, please refer my previous tutorial. Now here, instead of defining cosine distance method like we did in earlier previous tutorial, where we use numpy module to fetch the distance, cosine distance, we will be using spatial library, and we will be importing distance from scipy, and then we will create a function again. Let's define a function to create a list where we will be finding the distance between each query vector, which is our review, and the embeddings, class embeddings. So we will be finding the distance between each of the query vector with each of the embeddings, and whichever is closest, we will just save that in a list. So let's create a distance empty list, and again for index comma embeddings, we will be fetching embeddings, and then we will be finding the distance using distance dot cosine between the query vector and the embedding. So query vector is a review, and we are looping through each of the class embedding and then comparing the distance. Whichever class is closest to the comment or review embedding, we'll store it in the distance dot append. So for each review, we have a distance along with the index of the class, and all we have to return is minimum of this distance value in the distances, right? Minimum of this distance let's name it as distances. So minimum of this distance value we will be returning using minimum function, and we are fetching the value and we are getting the minimum value out of it. Now we have created a function, and now we can finally apply this function to classify the review. So what we will be doing, we will be applying this find closest on each of the review, and so again we will browse through each review. Right, in the top 5 list we will identify the closest, which is returned by this find closest, where we are passing the review embedding of belonging to from the list review underscore embedding for the embeddings which we have created for each of the review, and we will also pass class embeddings. Let's see what this closest is returning. So it returns the dictionary, something like the distance, the minimum distance which is it has identified, and the position of the index in the class embeddings, which is 0 in this case, but it can vary from 0, 1, 2, right, because there are 3 sentiments. And now what we will do, we will refer our sentiments dictionary to fetch the index, fetch the emotion from the index. And for that, what we can do, we can create a variable label equal to sentiments. We can go to the return value of the closest dictionary. From there we can fetch the index of the review sentiment identified, and then we can fetch the label from the sentiments dictionary. Let's print the label. We can see that it marks the first review as negative and rest of the 3 reviews as positive and 1 review as neutral. And let's have a quick look at the comments, and if you will have a look, that first review is actually negative, and this one is positive, and this one was also positive. Maybe this seems like a neutral, and then there is again a positive review, and so this result seems to be fine. But in some cases you will see that it is not enough to describe the sentiment in one word, positive, neutral or negative. LLM might need more information to classify it in a better way. So what we can do, we can have class descriptions. Maybe we can have one more key over here as description to define more about the sentiment, and then we can create embeddings for those descriptions. So right now I'm directly defining class descriptions over here. This is in accordance with the index. Effectively we will be generating embeddings for these instead of just one word, and that should give you better context and better accuracy for the sentiments. Now further to this, what we can do, we can append the result list with again a dictionary for each review with the review, its predicted sentiment with a value label. So we have this final list over here. We can create a data frame out of it again in order to better view the results through pandas data frame method. Let's display this. It's just 5 rows in our case because we have chosen just 5 reviews. If you see, earlier it gave neutral review for this, now it is giving positive review. Here in this case it's applied more information to the LLM that neutral review has no strong feelings while negative review has dissatisfaction, positive review express satisfaction. So the review comment which was identified as neutral earlier is now identified as a positive review. Clearly we can see this is more accurate information. So with this we are done with an example of review sentiment classification through OpenAI Embeddings. I hope this lesson gave you a good hands-on practice to understand the basic concepts of embeddings and how to calculate the similarity between 2 documents. However, this approach isn't scalable for real-world applications, especially when working with large data sets and high-dimensional embeddings. In the next lesson, we will explore an essential concept for building scalable AI application, the vector databases. and this will help you efficiently handle and search embeddings at scale, and it is a key building block in your AI journey. And in case you are finding these videos helpful, please like, comment, and don't forget to subscribe. I'll see you in the next lesson.